Hey everyone, welcome back to Python code Nemesis. In today's video, we'll be reading about the different kinds of joins that SQLAlchemy has and a few more miscellaneous topics. So let's get started. In today's video, we learn about differences between one and scalar in SQLAlchemy, inner join, left outer join, right outer join, full outer join, and cross join. The difference between one and scalar in SQLAlchemy. The one function is used to retrieve a single result from a query. It assumes the query will return exactly one row. It raises an exception if the query returns no rows or more than one row. Here's an example, and in this example, the query retrieves a user object with an ID equal to 1. If the query returns exactly one row, the one function will return that row as an object. If the query returns no rows or more than one row, it will raise an exception. Scalar function. The scalar function is used to retrieve a single scalar value from a query. It assumes that the query will return a single column from a single row, and it raises an exception if the query returns no rows or more than one row. So here's an example. Count is equal to session.query func.count user ID, which counts the number of rows in the user table by using the count function, and the scalar function retrieves the single scalar value returned by the query. If the query returns no rows or more than one row, this will raise an exception. So in summary, the one was used to retrieve a single object from a query, while scalar is used to retrieve a single scalar value from a query. Moving on. Joins in SQLAlchemy. In SQLAlchemy, the default join type is an inner join, which is very, very important. When you perform a join without specifying the join type explicitly, SQLAlchemy assumes it to be an inner join. So this is an example where there are two tables, table 1 and table 2 to join, and there's this condition where table1.id is equal to table2.table1 underscore id. So in this example, the join method is used to join table 1 and table 2 on the condition. If the join type is not specified like it is here, SQLAlchemy defaults to an inner join. If you want to explicitly perform a left outer join, then you can specify using the join method here with a parameter isOuter is equal to true. There's a bunch of parameters like full, isOuter, which let you specify what kind of join you want to do. So let's move on and understand these in more detail. So an inner join returns only the rows which have matching values in both tables being joined. So table 1 and table 2, when they are joined on this condition, they have to have matching values in both the tables. In left join returns all the rows from the left table and the matching rows, only the matching rows from the right table. And if there is no match, it returns null values for the columns of the right table. So this is the syntax with an isOuter is true, which is basically a left outer join. A right outer join returns all the rows from the right table because this is a right outer join. So the outer portion right has all the rows and just return the matching rows from the left side. And if there's no match, it returns null values for the columns of the left table. So here's the SQLAlchemy code, which is same as the outer one, where you just do a from statement, right join table1 or table1.id is equal to table2.table1id. So this is like explicitly passing in the raw SQL statement. Instead of this, you could just swap your table1 and table2 and like just perform a left outer join with swapped tables so that it's a right outer join. Yeah. A full join or full outer join returns all the rows from both tables, including the unmatched rows. If there is no match, it returns null values for the columns of the table without a matching row. SQLAlchemy code, session.query table1, table2 dot join table2 and table1.id is equal to table2.table1id. Full is equal to true. Cross join or Cartesian join. It has a different function called cross underscore join or cross join. Returns the Cartesian product of both tables, resulting in a possible combination of rows. SQLAlchemy code. So as you can see, this is the SQLAlchemy code. Now we have a DIY section where we have the complete code, a demo to execute each type of join and see how it's working. So we have first created an engine called SQLite join demo.db, binded that engine to a session, created a new session, and for the base model, we have created a base class with SQLAlchemy's declarative base. We'll define how the table models work. So the table name is table1 and there's an ID column, there's name, and then there's a relationship table2 rows, which is relationship with table2 that's defined. Here, the ID column is the primary key. In table2 as well, ID column is the primary key. Table1.id is a foreign key for table1.id, so it's mentioned that, and name is column string. So create the tables. This is how you create the tables, and then insert some sample data. Table1 data with some name, table1 row 1, and IDs. Session.bulk save objects. Similarly, insert some data into table2. And then there's an inner join, so inner join.query, just same as what we had seen in the above example and syntax. There's an inner join, there's left join, there's right join, which is outer joins again, full join and cross join. So this code sets up a SQLite database with two tables, table1 and table2, and demonstrates each type of join query using SQLAlchemy. I would encourage you to write this code yourself or like copy paste this part of the code into a file called, let's say, python demo.py, and like change these values, insert your own names, add more entries into the table, and see how all of these joins are performing. You can run this file with Python and the name of the file that you save it with. So go ahead and like try different kinds of joins with this and see what is working, if something is not working, if some syntax has gotten updated, if something has changed, go research, go to SQLAlchemy's official documentation, find out. Yeah, it'll be fun. So in conclusion, SQLAlchemy offers a powerful and flexible framework for working with databases in Python. One of its key strengths lies in the support for various types of joins, including inner join, left outer join, right outer join, full outer join, and cross join. Joins enable the combination of data from multiple tables based on certain conditions, allowing for comprehensive and effective data retrieval and analysis. SQLAlchemy provides a user-friendly syntax for performing joins, making it easier for developers to write complex queries and access the desired information from related tables. By leveraging SQLAlchemy's join capabilities, developers can enhance their database operations, gain insights from interconnected data, and optimize their application's performance. That's it for this article. Feel free to leave feedback or questions in the comments. If you found this an exciting read, leave some claps and follow. Subscribe to my channel, check out my PMC link, and have a nice day. Keep coding.